Okay, so we got a demonstration where it sort of kind of covers the idea that, hey, pressure affects reactions. Now, in truth, if we have a reactant or product on a reversible system that is affected by pressure, or gases are certainly more affected by pressure than other phases of matter. If we compress a gas, which is much easier to do than a solid, liquid, or gas, you're going to put them closer together. Obviously, the distance between them is, for the same thermal energy, is going to make them react or collide more often. Thus, the number of effective collisions increases, and thus the rate of reaction increases. So, this demonstration sort of kind of covers it. I think it's fun anyway to do. What I'm going to do is take some methanol, which is certainly very flammable, and soak some alcohol onto some paper here. I'm going to light it without lighting my hand, which is soaked in alcohol too. Okay. And maybe I'll get my hand out of here fast enough. Okay, good. Now, that's a lot more fire than I wanted. Okay, however, more is better, I guess. Now, what I'm going to do is I'm going to spin this once the fire goes down a little bit. And by spinning and creating a vortex with the screen, okay, by spinning it, remember Bernoulli's effect, if you organize the air in a certain motion, it spends less time pushing out. So what am I going to do to the pressure? Decreasing. You guys, inside of a tornado, the pressure is lower. Inside of a storm that's turning, like a hurricane, the eye of the hurricane, they measure the potency of the hurricane, the strength, by the low pressure area. So if we've got a turning motion, you have a low pressure. So I'm going to create a low pressure area by spinning the air in a circular motion, which means it spends less time pushing on it. Now, it's not exactly what I'm talking about here, but it's fun to do. All right, so in any case, let's change the pressure. And by lowering the pressure, sort of, it's actually not perfect here. It's kind of spinning on me. Imagine that. But by lowering the pressure on it, we see the flame go what? Higher. Now, that's not exactly what I'm talking about. I know that when I increase the pressure on reactants, the rate of reaction increases. But still a fun demonstration to do nonetheless. Okay? So, in any case, enough of that. I don't want to melt everything. Okay, it'd be nice if I got the fire. Nice if I had some water. I'm probably melting my lazy Susan. Okay, more or less. Okay.